Example 3 wants us to find the derivative of the function 2x minus 1 over 3x plus 5. So we're going to need to use the quotient rule. So you have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's go ahead and simplify that. So if I multiply 2 in, we get 6x plus 10 minus, I'm going to distribute the 3 and the minus sign, so that gives us minus 6x plus 3 all over 3x plus 5 squared. And then if we simplify that, we get 13 over 3x plus 5 squared. Part B wants us to find the equation of the tangent line of f of x at x equals 1. We've found the derivative in part A, so let's first evaluate f prime of 1. So that's going to be 13 over 3 times 1 plus 5 squared, which is 13 over 3 plus 5 is 8, and 8 squared is 64. So that is the slope at that location. And we also need to evaluate f of 1. So that's going to be 2 times 1 minus 1 over 3 times 1 plus 5. And the numerator will simplify to 1, and then the denominator would simplify to 8. So the ordered pair that we're looking at is 1 comma 1/8. So if we were using point slope form, then we'd have y minus 1/8 is equal to 13 over 64 times x minus 1. And I'm just going to go ahead and leave it like that in point slope form. Example 4 asks us to find all points on the graph of f of x is equal to the quantity x squared plus x minus 1 all over x squared minus x plus 1, where the tangent line is horizontal. So the first thing that we need to do is we need to find the derivative. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let's simplify the numerator. This is quite long, so bear with me. So we have 2x cubed plus x squared minus 2x squared minus x plus 2x plus 1 minus the quantity 2x squared note that should be 2x cubed minus x squared plus 2x squared minus x minus 2x plus 1 all over that denominator squared. So if we simplify the numerator, let's see, so 2x cubed minus 2x cubed, those will cancel out. And then we can combine some like terms. So we have negative x squared plus x plus 1 minus x squared minus 3x plus 1 over the denominator squared. And then we need to distribute that negative sign. So we'll get negative x squared plus x plus 1 minus x squared plus 3x minus 1 over x squared minus x plus 1 squared. And finally we get negative 2x squared plus 4x. And then this plus 1 and this minus 1 will cancel out all over our denominator. So we found the derivative, and we want to figure out where the derivative is equal to 0. And whenever you're dealing with a rational function and you're setting it equal to 0, it's going to equal 0 whenever the numerator equals 0. So technically at this point we can ignore the denominator, and we basically just want to solve when the numerator of our derivative is equal to 0. And one thing that we can do is we can factor out an x. So we have x times negative 2x plus 4 is equal to 0. And if we use the zero product principle, we can set both of those factors equal to 0. And we get, let's see, negative 2x equals negative 4. And then if we divide both sides by negative 2, we get x equals positive 2. Okay, so that means that f of x has horizontal tangent lines when x equals 0 and maybe that should say or x equals 2. So those are our two values there.